Question right here to help us remember how we multiply decimals with any whole number. So if you have a decimal like 0.1 and it is multiplied by 10, what will be our answer? So in this case, the decimal place will move to your right, so we will have 1 being our value. So another way you can be able to solve this is to express the first number, which is a decimal, as a fraction. So 0.1 will be 1 over 10, and then we multiply it by 10. Now when you have zeros, you know that we can cancel out these zeros, so our answer will remain as 1 times 1, which is 1. Another example is 0.12. So if we are multiplying 0.12 multiplied by 10, what will happen? The decimal place moves 1 step to your right. So if we had 0.12 as our number, and the decimal place is to move to your right, it means it gets to move to this point where it becomes in between 1 and 2. So writing that is 1.2, and that can be written as 1.2. Another way is, if you have to do the multiplication bit of it, then you'll have to change the number first to a fraction. So 0.12 has 2 decimal places, so in writing it as a fraction, we'll write it as 12 over 100, and then we multiply by the 10. So of course, if you see the zeros up and below, you can be able to cancel out one at a time. So this 0 will cancel this, so we will remain with our number as 12 divide by 10, and this will mean this is 1.2. The 10 introduces 1 decimal place in our value, that is in the numerator. All right, with that in mind, then we can be able to look at how to change a recurring decimal to a fraction. All right, so let's take an example of 0.5 recurring. Now for any recurring decimal, if there's only 1 dot above the number, it means we have only 1 digit that is recurring. So this is the same as 0.5555, and it continues on and on. Recurring means it's endless. So what are we gonna do in this case? We are going to let a letter, so a letter of your choice, you can use X, Y, Z, yeah. So let a letter represent the fraction that you are thinking about, the fraction that you wanna find. Okay, all right. So this fraction changed to a decimal is the one that gives us the 0.555 recurring. So the fraction changed to a decimal will give us 0.555 recurring. Now the next step you're gonna do is multiply this fraction by 10, 100, 1,000, and so on. So you're basically multiplying by powers of 10. Now when there's only 1 number that is recurring, you're going to multiply by just 10. So if I multiply x times 10, I get 10x. If I multiply 10 times this number that is recurring, we had seen that if you multiply a 10 to any decimal number, the decimal moves to your right. So this decimal place is going to move 1 step to your right, right there. So our value after multiplying by 10 will be 5.555 and this is a recurring decimal. So the next step is subtract the first equation from the second equation. So assume this was my first equation and then this was the second equation. I'm going to subtract the first equation from the second equation. So of course the second one starts and then the first. So let me rewrite that so that you can be able to follow it ever so clearly. So we have the second one, which is 10x is equals to 5.555. Subtract the first one, which is x is equal to 0.555. So I'll put this dot to ensure that I am indicating that that is a recurring decimal. So I'm gonna put a line right here and then subtract these values. Now from my right hand side, if I subtract all these fives, they give me 0. They give me a 0 at this point, a 0, a 0, so many zeros. And then on this other side of the decimal place, 5 take away 0 is just a 5 equals to 10x take away x. Now when we have 10x take away x, when it's just x, it means that it's only 1x. So we are subtracting 10 minus 1 and that gives us 9x. So 9x is equals to 5. So what will be the value of x? You divide both sides by 9. So this will cancel out, the 9 will cancel out with the 9. So you remain with your value of x as 5/9, and that will be your fraction. So in this second example, I'm going to have a decimal that has 2 digits that are recurring. So the example that we're going to use is 0.84, and both 8 and 4 are recurring in this case. So the first step we said is to let a value, the value of the fraction be represented by a letter. So let x represent the fraction that we are looking for. Yeah, so x, which is the fraction changed to a decimal, should be equal to 0.8484 recurring. Now the next step is to multiply by 10, 100, 1,000, depending on the number of digits that are recurring. In this case, we have 2 digits that are recurring, so we are going to multiply by 100. When it's only 1 digit that is recurring, we multiply by 10. So 100x is equals to, so these are 2 zeros, so my decimal place is going to move 2 steps to my right. So 1, 2. Alright, so in that case then I'll have 84.8484 recurring. Alright, so this is the first equation and then this is the second equation. So what I'm going to do is subtract the second equation and the first equation. So that is what I'm going to do. So for me to be able to subtract them really easily, I'm going to start with the second equation. So the second equation is 100x equals to 84.8484 recurring. So this is so endless, I'll stop at that point. And then the first equation is x equals to 0.8484 ... So I'm subtracting these 2 equations, so I'll put a line right there so that I show that I am subtracting. So once I subtract, I'll start with my right hand side. 4 take away 4 is 0. 8 take away 8 is 0, 4 take away 4 is 0, 8 take away 8 is 0, and then we have the decimal place, we drop it right there. 4 take away 0 is a 4, and then 8 take away nothing is 8. So you will notice that as I continue, all these numbers will be recurring. So of course there will be so many zeros, but I don't need to indicate that. So the next step is to come and subtract this other side. So in this case, we have 100x take away an x. So when there's only an x, it means there's just a 1 that is right there. Okay, so 100x minus 1x gives you 99x. All right, so once we have done that, then I'm going to rewrite this equation as 99x is equal to 84. So I'll come to this side. If 99x is equal to 84, what will be the value of x? So I'm going to divide 99 on both sides so that I remain with an x on my left hand side. So when I divide by 99, this will cancel out. It's more or less like dividing each other out. So I'll remain with an x on my left hand side, so that is an x right there, and then on my right hand side I'll remain with 84 over 99. This is a fraction, but you have to ask yourself, can you be able to simplify it further? Are they even numbers? No. So 2 is not a factor. How about 3? 84 and 99 are factors of 3. So 3 divides 84 how many times? So 3 goes into 8 2 times, and we have so 2 times gives you 6. So if it's 6, we have a 2 remaining, 24. 3 goes into 24 how many times? 8 times. Now 3 divides 99 how many times? 33 times. Is there any other factor that is common between 28 and 33? Not at all.
This last question presents a recurring decimal that has 3 digits that are recurring. So if we have a number like 0.169 and the dot has been put in the first digit and the last digit, it means that all these digits are actually recurring. So this is the same as 0.169, 169, 169, and so on. Yeah, so we are going to use a letter to represent the fraction that we are looking for. So let y, so this time around I want to use y. Let y represent the fraction. So we are going to have y as a fraction, and changed as a decimal it should be 0.169 recurring. So because we have 3 digits that are recurring in this case, we're going to multiply the number by 1000. So if you multiply y times 1000, it will give you 1000y is equal to, now the 1000 will mark this decimal place to move 3 steps to your right. So 1, 2, 3. That will be the first, the new place of where the decimal place will be at. So I'm going to rewrite that. So I'll have 169.169 recurring. So this is the first equation, this is the second equation. The next step is to subtract the second equation and the first one. Yeah, so I'm going to subtract those 2 equations. Let me start with the bigger one. 1000y, which is 169.169 169, 169 recurring, subtract the y, which is 0. So I'm aligning these numbers so that they are just below each other, starting from where the decimal plate is going forward. So I'm going to put a line right there and then subtract these numbers. Yeah, so starting from my right hand side, 9 take away 9 is 0, 6 take away 6, 0, 1 take away 1, 0, 9 take away 9, 0, 0, 0, and then I have a decimal place right here. 9 take away 0 is 9, 6 take away nothing is 6, 1 take away nothing is 1, and then I put an equal sign right there. Now this is 1000y take away y, so when we have a letter, that means there's just a 1 right here, 1y. So I'm gonna put the 1 there so that it helps us understand how to subtract those numbers. So 1000 take away 1, 1000 take away 1 is 999y. So I'm going to rewrite those numbers that I have. So 999y is equal to 169. So to remain with y, I'm going to divide 999 on both sides. So divide 999. So the next thing that will be, these are going to divide each other out. So I'll remain with the y as 169 over 999. And because there's no factor that is common between 169 and 999, then our fraction will remain as it is.